Okay, so here is sorry, excuse me. That example 727. I changed it from last year's, so it's an updated one with the trig equation. So we're supposed to find the extrema, which means max mins, and then concavity, inflection points, concave up, concave down business. First thing we need to do is find the first derivative, which is 1/2 minus cosine of x. So we'll set that equal to 0. Move cosine over. So we're going to know when is cosine x equal 1/2. Now, I should have said this in class. Hopefully I did. I forgot to type this in. We're going to work on a domain from 0 to 2 pi just to make this so we don't have to keep doing every 2 pi units and the repetitions that would occur. But we have cosine of x is 1/2, so we have to look up on a unit circle when does that occur. Now 1/2 means it's the 30, 60, 90 triangle with hypotenuse 2, adjacent 1, opposite root 3. That happens when this is a 60-degree angle. Okay, but you got to remember this also happens in the fourth quadrant as well. If we're going from 0, pi over 2, pi, 3 pi over 2, back to 2 pi. It happens twice. 60 degrees, though, is pi over 3. And then we're 60 degrees reference angle again, which means we're actually going to be pi over 3 short of 2 pi. So that means we're also at 5 pi over 3. That's sloppy, but it's 5 pi over 3. So there are two values we're looking at. So I'm going to look at my number line then for increasing, decreasing. Pi over 3, 5 pi over 3, 0, 0. Now, what we got to realize is that I'm trying to figure out when is cosine of x bigger than 1/2. Because whenever cosine's bigger than 1/2, we're going to get a negative value. And so if, again, going back to my unit circle, when I'm at 60, I'm taller than I am wide, so that's why this is 1/2. This is root 3 over 2. But when I go to like 30 degrees, this is root 3 over 2. This is 1/2. So from 0, and actually even 0, cosine of 0 is 1. So 1/2 minus 1, this is negative here. Now over here in the second and third quadrants, we can do this quickly. Cosine's negative. So 1/2 minus a negative is actually going to be a positive number. So we're positive here. And then after that again, we're going same thing in the fourth quadrant, negative. So we have increasing from pi over 3 to 5 pi over 3, decreasing from 0 to pi over 3, and from 5 pi over 3 to 2 pi. Okay. That also means we have a min at pi over 3 of, now I plug this in, 1/2 of pi over 3 is pi over 6, minus sine of pi over 3, which is root 3 over 2. So it's a weird one. There's your min, pi over 6 minus root 3 over 2. You have a max then at x equals 5 pi over 3 of, again, plug 5 pi over 3 in, well that's 5 pi over 6. Minus, now here's the deal, I'm going to plug in 5 pi over 3, that's going to actually give me a negative root 3 over 2, so plus root 3 over 2. I'm at the screen, aren't I? Sorry. So when I do down here, that's sine of 5 pi over 3. I know I've got a bunch of sloppiness, but it ends up being root 3 over 2. There's your max. Now the second part of this then is concavity and inflection points. So I'm going to take this function of 1/2 minus cosine x and find the derivative of that. Sorry, I'm grabbing a second sheet of paper real quick. So if f prime of x, whoops, out of screen, it's 1/2 minus cosine of x. F double prime of x is just going to be 1/2's gone. Derivative of cosine is negative sine. It's actually positive sine x, which just makes this really easy then, because we want to know when does sine of x equal 0. Well, for 0 and 2 pi, it's at 0, so that I can go test that, but it's also at pi. and 2 pi. So I really only have to check one spot because both these guys will be 0. So sine before pi is positive, sine after pi is negative, because that's what we're looking at here. So this is, again, really easy second derivative stuff. So you have concave up from 0 to pi. You have concave down from pi to 2 pi. And then your inflection point will be at pi, and then again, remember f of x was 1/2 x minus sine x. Well, that'll be 1/2 pi minus 0, so just 1/2 pi. Now, just to get a look at this graph, just to kind of see it. F of x equals 0.5 x minus sine x. So there's the graph. No, I don't want to I'm going to go down the page. And you can see here from 0, so it says 1, but let me change the x scale here. My graphics units, x-axis units. Let's see here, graphics. Can I do? No, I guess it's the best I can do. So yeah, so if I do like this point here, pi divided by 3, comma, f of pi divided by 3. That's 0.8. There's that minimum. Okay. You can see it decreases. Then I had a maximum at 5 pi over 3. 5 pi divided by 3, comma, f of 5 pi divided by 3. There we go there. So there's your min, there's your max. Your inflection point's pi comma pi over 2. There's the inflection point. So there's all of our behaviors. Again, we're only looking at this from, I think I can do this. We do parentheses 0, comma 2 pi. Yeah, whatever. I don't mess with the piecewise business. Yeah. So there we go. That's the graph. And if you have any questions, send me an email or I guess see me before school. Thanks.